The global battle for the future isn't being fought over silicon. It's not about microchips, algorithms, or software. We've all been watching the wrong war. The real fight, the one that will determine the next century of power, is about something far more fundamental: electricity. While America has been busy building the world's most advanced AI brains, it forgot to build a power socket strong enough to plug them into. And across the Pacific, China has been quietly building the world's biggest extension cord, one designed to power a technological empire. What happens when the most advanced minds have nowhere to get their energy? The answer is rewriting the rules of global power as we speak. For years, we've been told a simple story about the future. It's a story of a great power rivalry between the United States and China, and at its heart is the semiconductor. The narrative is compelling and easy to grasp. The US, with design giants like NVIDIA, holds the keys to the kingdom, the advanced GPUs essential for training large language models. Washington has wielded this advantage like a weapon, hitting Beijing with strict export controls to cut it off from the highest levels of artificial intelligence. On the surface, it looks like a winning move. This focus has created a kind of tunnel vision, a global obsession with who has the fastest chip. The markets, the politicians, and the media have all bought into this narrative. It's a contest of intellectual horsepower, a race to build a better brain. We track every new chip announcement like it's the definitive score in this geopolitical Super Bowl. This has been the central drama of the 21st century tech race. American innovation versus Chinese ambition, played out on a tiny sliver of silicon. But that story, as convincing as it is dangerously incomplete. It's like watching a chess match and only paying attention to the queen. The obsession with chips has blinded the world to a far more decisive front in the AI race. It's a battlefield measured not in teraflops, but in terawatts. While the West celebrated its dominance in chip design, it overlooked the simple, brutal reality that every single one of those chips is useless without a vast, constant supply of electricity. And on this battlefield, the one defined by raw power, China isn't just competing. It's building an advantage so profound it threatens to make America's chip leadership irrelevant. An AI model isn't just a piece of software. It is a voracious beast. Training a single frontier-level AI model can consume a staggering amount of electricity, as much as tens of thousands of households use in a year. Running it day in and day out for billions of users requires a constant, stable, and massive flow of power. This is the great, unacknowledged bottleneck of the AI revolution. It's not about how fast you can compute, it's about how much energy you can feed the machine. And it's here, in the unglamorous world of power grids, that the United States is facing a crisis. For nearly 2 decades, electricity demand in the US was basically flat, but AI changed that overnight. Data centers, once a rounding error in national power consumption, are now the single fastest growing source of new demand. In 2023, data centers already accounted for about 4% of total US electricity use. By 2030, projections from groups like the Electric Power Research Institute and the Department of Energy suggest that share could balloon to anywhere from 9% to 17%. This surge has collided with an American power grid that is aging, fragmented, and notoriously difficult to upgrade. It can take 2 years to build a state-of-the-art data center, but over a decade to permit and build the high-voltage transmission lines needed to power it. As of the mid-2020s, there were around 2,300 to 2,600 gigawatts of energy projects, more than the entire installed capacity of the US grid, stuck in interconnection queues, waiting years just for approval to connect. This has created a bizarre paradox. The world's most advanced AI companies are desperately trying to build out their infrastructure, but they are increasingly finding that there's simply nowhere to plug in. Grid operators are now openly discussing the need to cut power to new data centers during shortages, and some states are even weighing moratoriums on new construction. The primary constraint on the growth of American AI is no longer capital or even chips. It's the physical inability of the nation's infrastructure to deliver reliable power. While America grapples with its power deficit, China is executing a strategy of breathtaking scale. Beijing has recognized that leadership in the AI era isn't just a technology problem, but an infrastructure and energy problem. The result is a national policy doctrine with no parallel in the West, computing electricity coordination, or Suandian Sietong. This concept, now a cornerstone of national planning, treats data centers and the power grid as a single integrated system to be built in tandem. The core of this strategy is to move the power-hungry work of AI to where the power is. Through a massive project called Eastern Data, Western Computing, China is building enormous national computing hubs in its vast, sparsely populated western provinces, regions rich in renewable energy. Instead of struggling to move power to the data centers, China is moving the data centers to the power. Within some of these major new hubs, the government has set ambitious targets, requiring new data centers to source 80% or more of their electricity from clean sources. A data center in Inner Mongolia might be directly connected to hundreds of megawatts of dedicated wind and solar power. To connect this new digital infrastructure, China is deploying its secret weapon, ultra-high voltage transmission lines. These are energy superhighways capable of transmitting massive amounts of electricity over thousands of miles with minimal loss. China operates more of these lines than the rest of the world combined, allowing it to move clean energy from the sun-drenched deserts and windy plains of the West to the bustling cities of the East. The scale of this build-out is staggering. China's electricity consumption is already more than double the US level, and its 15th five-year plan calls for non-fossil energy to become the main source of electricity by 2030. The country is treating AI as a grid planning problem, aiming to turn data centers from a stressor on the grid into a flexible, manageable component of it. This is industrial policy on a civilizational scale. The contrast with the United States couldn't be more stark. While China executes a top-down, centrally planned energy revolution, the US is tangled in a web of regulatory hurdles, political gridlock, and fragmented markets. The American grid isn't one system, it's a patchwork of regional operators and private utilities, often with conflicting interests. This decentralized structure has become a critical vulnerability in the face of the AI energy boom. The numbers tell the story. One analysis from the International Energy Agency suggests that data centers accounted for around half of all electricity demand growth in the US last year. In China, while the absolute demand from data centers is also growing rapidly, its proportion of the country's overall energy growth is much smaller because the entire energy system is expanding at a colossal rate. In the US, data centers are an earthquake stressing a brittle system. In China, they are a large wave in a rapidly rising tide. The problem in the US is one of institutional failure. There is no single entity responsible for aligning the explosive growth of AI with the nation's power capacity. A tech company can plan a gigawatt-scale data center campus in under 2 years, but the utility that has to power it may need a decade or more to build the infrastructure. We're already seeing the consequences. In Virginia, a major data center hub, local pushback over surging electricity demand is growing. In Texas, the grid operator ERCOT has seen requests for new large-scale connections that, in total, are several times the state's all-time peak demand, prompting the governor to call for an audit of data center projects. American innovation is, quite literally, being throttled by a lack of power sockets. This emerging electron gap has profound geopolitical implications. For years, America's main tool of technological statecraft has been restricting China's access to advanced chips. But what if China's massive energy advantage offers a strategic end run around those sanctions? While China may not have the most efficient 3-nanometer chips from NVIDIA, it has something else: a monumental and growing supply of electricity. This changes the entire calculus. China is attempting to compensate for using less efficient domestic chips by simply using more of them, powered by its vast energy infrastructure. Now, linking together massive clusters of slower chips isn't a perfect fix, because thousands of graphics processing units struggle to communicate fast enough to act as one giant brain. But China is betting that raw scale and endless power will eventually brute force a solution to this problem. Think of it like this. The US may have a tightly synced racing team of Ferraris, but it's starting to worry about the price and availability of gas. China is building a massive, sprawling fleet of reliable sedans and owns the gas station next door. In a long-distance race, who has the advantage? This energy strategy makes China far more resilient to American pressure. You can stop a shipment of microchips at a port. It's much harder to sanction a terawatt of installed power capacity or 1,000 miles of ultra-high voltage transmission lines already built on sovereign soil. While not totally immune to foreign pressure on supply chains, China is building a foundation for its tech ambitions that is domestic, integrated, and less vulnerable to traditional economic warfare. It's a holistic approach to industrial power that the fragmented, market-driven system in the West struggles to counter. The story of China's power build-out is also tangled up with the global climate crisis. And here, the picture is complicated. On one hand, China is using its AI ambitions as a catalyst for a massive expansion of renewable energy. The Eastern Data, Western computing strategy is explicitly designed to pair data centers with the country's best solar and wind resources. In this view, AI's insatiable energy demand is accelerating China's green transition on a scale the world has never seen. However, there's a more skeptical take. The sheer speed of AI-driven electricity demand is so immense that it could force China to keep its massive coal fleet running, or even expand it, to ensure the grid remains stable 24/7. The intermittency of wind and solar means that, for now, coal is often the reliable backup. This could lead to a paradox where China becomes the world's leading producer of both green energy and carbon emissions simultaneously. This is the great question at the heart of China's strategy. Is AI the killer app that will finally unlock a renewable energy future? Or is it a new, carbon-intensive industrial revolution that will lock in fossil fuel dependence for decades to come? China is conducting a world historical experiment in real time, and the outcome is far from certain for both the AI race and the future of the planet. This invisible battle, fought with power plants and transmission lines, is what will truly define the coming decades. Understanding these hidden forces, from technology and energy to geopolitics, is more critical than ever. If you want to keep exploring the deep structures that shape our world, make sure you're subscribed. For too long, the race for AI supremacy has been misunderstood. It was never just about algorithms or silicon. It's fast becoming a contest of industrial will, national infrastructure, and raw physical power. The United States still holds a formidable lead in designing the most advanced AI models and the chips that run them. But that lead is built on a fragile foundation, a power grid designed for a different century that is now buckling under the strain. China, through deliberate and massively scaled industrial policy, has laid a different foundation. It's one of steel and concrete, of transmission towers and solar farms, built on the conviction that in the 21st century, computational power and electrical power are two sides of the same coin. We're entering a new era, one where the cost of intelligence is converging with the cost of energy. In this era, the ultimate competitive advantage might not belong to the nation that designs the most elegant engine, but to the one that can produce the most fuel. The West has focused on building a faster car. China has focused on building the world's biggest gas station. As the race gets longer and the demand for fuel grows, we're about to find out which strategy was the right one.